The thing is,
Yeah.
So the make exams thing says that one of the problems with this is AC or more complicated. We haven't really talked about AC much. Is that still something we're going to do?
I'll mention it. We have, but I haven't specifically. So I'll show you what I mean by that. Okay. That is weird. You said that. Media. Okay. Sorry about a few minutes late today. Okay, questions? Anybody have any questions? Yes. Yeah. It may be. So what he's asking about is he came over and we went through the quiz, and because one of the numbers was really small, it ends up having like, and if I do like a 1% tolerance, it's still not quite there. So, and if I do a 20%, it's like too much. So it's hard to find sometimes that range. So if you feel like your method is like, oh, this does match up with my solution, you know, the solution that I posted on there, feel free to reach out to like the grader and say, you know, I discussed this, it looks like this should be close enough. And so the method is more what I'm really looking at. So try not to get like really hung up on the numbers themselves, but more the methods that are in there. So he was asking, you know, is that issue also going to be with some of the unit 2 practice problems? And you may also get those. So if you end up going through the problem and it's more just the math, like your methods are the same, it's just a math difference, I wouldn't don't dwell on those. Focus on more the math equations and then how that solution is derived. Okay. Does that sound good? Okay, yes.
Isn't your assignment the problem with the AC input source more complicated? Have you done?
Yeah. So Andrew is asking me about that. So yes, we have, and you just didn't know that that was what it was. So a more complicated input source is one that is just not 5 amps, 5 volts. So anything like, you know, you can have a cosine, you could have, let me go back to some of these. Let's see.
The 16U turns.
Yeah, so that's more, I mean, not really, but yes, it is. So even those are, so like this would be an example of a more complicated input. So having a step function in there where it goes up and then this is described by that U of t, you know, minus something shifted. So this would be a more complicated input. So yeah, anything that's basic, I mean, and you can do, you know, sinusoids if you want to do a sinusoid instead. Those get to be a little messy. So we've been just doing more of the math of just like a step function or just anything after time 0. And so that's where that 7 U of t kind of comes with. So those are considered more complicated AC inputs than just a fixed DC voltage. Does that answer your question? And Andrew, okay, so yes, anything like that, you can still make it fairly simple if you want. Or you can make it more complicated and challenge yourself, but yeah, pretty much anything that would be considered like, yes, this is a complicated AC input.
Will the exam feature 4 questions? Will it be that kind of one circuit, one conceptual question like exam 1?
Exam 1 was an error. It was supposed to be 3 questions on there. One was supposed to be an RL, one was supposed to be an RC, and then an RLC circuit. So you ended up with just the combination of both. This one will have like some smaller questions, and some of those you'll get on that practice, you know, where it will be like, well, what element would be here in the drawing when you draw this? What would be the value for your initial values? So some of those smaller kind of parts of a question that either in there somewhere or, you know, something about that there'll be kind of a smaller part of it. And then there will be, you know, these circuits here where you have to solve the full circuit and do it from the S domain. So being able to do all of the steps of finding initial values, writing the equation, manipulating the equation to get to kind of a partial fraction expansion, and then understanding how to get those values from a partial fraction expansion and then going back into the time domain. So all those steps, some of them may be broken up a little bit here and there to try to eliminate if there was an error made. I can still, easily get graded, but all those steps are needed. And then the understanding question is more of those nuances that we've kind of gone over. You know, for example, like how do you write this equation mathematically or the signal mathematically? You know, being able to write those mathematically, being able to find the initial conditions. So understanding like I have to take it at this value and this is why. So those are the understanding questions that I'm looking for, is more on the usage during the solution of the problem. Does that make sense? Okay, all right. Any other questions? Okay, so hopefully that will help you be able to prepare now for the practicing for this next exam. That will be due next Tuesday. And I realized it is Halloween. Somebody pointed that out to me, so sorry. You do have an exam after the day after Halloween, but hopefully it will still be okay. No, the exam is on Wednesday. So your practice exam from your group is due on Tuesday, in preparation for your exam on Wednesday. Yes. The quadrant?
Yeah.
Okay. Yep. Okay, so his question is about quadrants and identifying which quadrant you're in, and then how do you find, is it the angle? Okay, and then how do you find the angle for that? So let's do some examples. So say you get a rectangular form that looks like this. Which quadrant are you in? Okay, so I'm going to draw first these quadrants to remind you which quadrant. So this would be, well, no, I'm not even going to draw them. Okay, so this would be quadrant 1. And what will be your angle? Yep. So if I was to draw this, the vector is going to be imaginary real. And so it's going to go over by 4 and up by 3. And then if I'm going to describe this in polar form, it would be r, which would be square root of 4 squared plus 3 squared. And then theta is the inverse tangent of 3 over 4. Okay. Let me give you a few to work on. Minus 4 plus 3j. And this minus, which one am I missing? Plus 4 minus 3j. So for each of these, I suggest just maybe drawing it until you can be like, oh, this is where it is. Just draw the vector itself. So I would draw each of these vectors and then look at changing them to the polar. And then hopefully from that, you'll see well, if so 3 over 4, I think is, what is that? Inverse tangent. That's 37 degrees. So this would be 37 degrees here. Yes.
And we would want to convert to polar when there is a complex conjugate in the numerator, or a division or multiplication between complex.
I have them on here. So you are going to want to have those because you're trying to get them into a form on this table. And typically it's been this form here. So yes, when they have complex conjugates.
Question.
Yep.
So when we do Laplace transforms on capacitors and inductors, there's both a series transform, like the power source is series with the with a capacitor, for example, and then they have a version of parallel with each other. What would you advise to use like either the parallel transform or series transform?
Depends on what you're kind of looking for too. So if your other elements are all in parallel, I would use the parallel form. If all of your elements are in series, then it's easy to say, oh, I'm going to use series. But there are more complicated situations where you're like, I don't know. And in those situations, it doesn't matter. It's going to still give you the same answer. And so if you can see, well, if I put this in series, then I could do just one node voltage here maybe. And so that would make one equation. So in situations where you're like, I can see like I only need one equation, if I use that form, that would be when I would use it. If you're like, I don't know, it's going to be 2 equations with each. So 6 of which one I want to pick.
Thank you.
Hopefully that helps.
It does.
Okay. All right. So go ahead. I would suggest drawing these vectors first and then finding. Here, I'll write this so you already know what the square root of 16 and 9 is. That square root of 25. I'll get to it. Okay, so where's this vector?
Third quadrant, third quadrant.
Okay, so you go over -4 and you go down -3. So it's going to be a vector right here. So the magnitude R is going to be the same, 5. And now the angle isn't going to be 37, right? Because 3/4 is going to actually give you a positive number. So you take the inverse tangent of -3 over -4. That actually gives you, a positive here. So you're going to, if you put that into your equation, it's just going to be 37 degrees. But that's not correct, right? Because it's actually coming around this. So what do you have to do to get to that location? So I would add 180 or you can go this direction. So for that direction, you're going to take, wait a minute. That one doesn't look as easy to me. 180. So this is, so 37 is going to be here. So it's going to be -90 minus that. That's more confusing. Don't do that one. Yeah, I'm going to stick with that one. Okay, so this is going to be then 180 plus 37, whatever that is. 217. Okay, where's this one? Okay, so it goes up over 4 and then up, so quadrant 2. And so what do you need to do here? So if you do inverse tangent of a minus or 3 over -4. And you said what? I heard somebody say it. Okay, let's look at see what this gives you. So that gives a -37 degrees. Which is going to give you, it's saying it's here, right? but that's not where it is. So if you add 180 and subtract off the negative 37, then that would give you the correct one. Yes.
So if we plug this equation into Wolfram, we just get the wrong values for the degrees every time.
Yeah.
And we're just supposed to figure out what quadrant to add.
Yeah.
values.
So you need to be careful with that. Yes. Yes. So yes, if you put it in Wolfram, it's going to mathematically come out as just 37 degrees because it's going to cancel out the negatives. So you need to look at that and say, well, if that's 37 degrees, that's not correct. If my rectangular form is -4 plus 3j.
But if we're dividing by another imaginary number, how would we figure out what quadrant? Like, let's say we have like that equation divided by like 100j. That's going to get.
So in Wolfram even, it gives you the numerator value and it will put it in rectangular form. And it's that's what you're converting into polar form. So you're not as concerned about the denominator, which is going to be used to actually translate it back to the time domain. You're only worried about the numerator value, like your A, B, or C value. And so that's why you can look at that and just say, well, that is in this quadrant. Does that make sense?
Mm-hmm.
So originally, yes, you're not going to be able to see any of those because it won't be in polar form. It will be in rectangular form. And then once it spits it out, it will be still in rectangular form. And then you can just look at the numerator value. All right. So this one ends up being 143 degrees. All right. This one is where so it's going to go over 4 and down -3. And so now when you do it, you're going to still get that negative 37 degrees, but that's going to be correct because you're in the right quadrant. Does that make sense? Hopefully clarify. Yeah. Okay. So do you understand when you're looking at these, what do these mean? And is the value you're seeing in Wolfram or whatever calculator, is it really correct or not? So that is one of these nuances with this, is just making sure you do get the right angle because that makes a big difference of where you are in there. And majority of the time, well, I won't say that. No, we're not going to get in that one. Okay. All righty. Okay, here's a little bit more complicated input. So this one we have IS of T is 9T e to the -3T U of T milliamps. And we want to determine I of T, which is the current going through R2, and then use R1 is 1, R2 is 3, and C is 1/3. So from this, what value will you use to find the initial voltages? Or initial voltage for VC? So for initial values, you need to know what is the source going to be. So that's going to be at time what? Time 0 minus. So that means at 0 minus, what is IS? Okay. So if that is 0, what's VC of 0 minus? Okay. Yes.
Question. Why do we know that IS is 0 minus 0? Is there a shift? The nature of the step function.
Yep. So because of that step function, all of that is multiplied by U of T. And so, anything before U of T is going to be 0. And then you only have that value starting at right after it's 0 plus.
Okay, so there's no shift. Okay.
No, this won't have a shift.
It was shifted by T minus 3.
So if it was UT minus 3, and you're still looking at it for I of T for T greater than or equal to 0, you're still going to look at it at T equals 0 minus. And that would still be 0 because it would be, or wait, is it shifted right or left? It would be shifted left. So, no, if it was T plus 3 and it was shifted left, so it actually had a value at 0 minus, then you would plug in at 0. So it'd be 9 times T at 0, e to the minus 3 of 0, which still gives you 0 in this case. All right, other questions? Okay, you guys go ahead and attempt to solve this. You can work in groups. Go through the solution.
But not getting them still.
That makes sense. Yeah. Yeah, let me see.
Well, I'm just gonna do IS, I need to, yeah, it'll be great. Yeah, but promise. You can see where then it makes everything work. Oh, I see. I think I'm going. Good progress. Where you guys? Yeah. Is that 19, you said I was 9. Oh yeah, no, that's.
Plug my DX in my.
And then you can see the I is just that B over R2. The I T is just a B over. Oh, okay, I was just looking at it.
So here it is. Well, here, I was.
I got your response. Yeah, but I it's like saw the error. And I also think I know where I would when I calculate yes, it's for the I did it with and I tried it again. You guys live in you think oh, it's right here. Not gonna press one. We over. You're right. What? I know for a 1+1/3. That goes to 4/3, and then I can just make this go to this or. Just so that can be like. Oh, sorry. So we should skip.
Yeah.
What's your A value? What? Big partial fraction, right?
Yeah, it was actually. I don't know.
Yeah. No, I had to have this factor. We did have this thing. Oh, there. I didn't get that. I mean,
It's, oh, it wants you to divide something out. Okay, that makes sense. If I really figure this out, it's like not really yet. It's what we have. Oh, wait, you-
So I said, for it's technically IX. And then I could just solve for VX, you know, I have my INC. Reaffirming that, I can.
If you know, it'd be- So it's like the same. Yes, you can either do VFX this way, or one of those.
Oh, okay, so essentially.
Do it this way. You can turn it down at the back. Oh. Do that, or you can do it this way. Right here.
Oh, okay. Oh, okay. Right, okay, because I would just also, this would be my.
Let me know when you guys get a final. Yeah, I don't think you do.
As your VX.
I didn't know. I didn't find out.
I got a plus R1 and it's like plus R2 here.
But I. Yeah, that IT deals. So.
Yeah, my.
So. You're going by backwards 3.
And then.
What?
I'm curious, sorry.
Take a picture of it. I split a lot of schools. Yeah.
Wait, that's interesting. Wait, you get. I guess you need I need to know this. This
How do you think that be doing it? Because all this is doing right
I'm curious now. Yes, that's then you said nine with that. When I do partial fraction decomposition, I think it's sparks to now we need to take out some operators for one of them. Let's say you're situated by these turns out. Maybe it's going like something like on, yeah.
It's something probably that's being sometimes as a positive spirit. And when I try to do that, it can be work.
You're talking about.
Oh, yeah.
We were there. Don't worry about it. I got like zero, and the A was the A with the S place in the beginning. Let me try doing these different. Way of part. You might have done.
You see this love aspect, because I just can't mentally comprehend doing that, so I do it like this.
And
Wait, so then you're, wait, did you, listen to this? So confused. You did so fast. I'm curious. Yeah, for A. Yeah, I'm just like, okay, how would I find? That's also good. I was trying to. So I do it the longer, but it took you. I was concerned to read it. We don't need each other. I'm going after. Right. I'm assuming there's like, three systems of equations. Well, yeah, you can see. Oh, I think A. Okay, if I didn't know A, technically, I told that A was. Wait, what did you say? That makes plus 7. Yeah, how can I solve this? It would be. There. So I will put my B value, right? This, I think this would. I think that's like even before, I think I've done, I did like I just couldn't connect to no, typically I would. If I did it, I would, yes. We just couldn't figure out like, I guess this is this, so it's. This one here, you just solve the effects.
Yeah, I figured it out.
Okay, questions?
I did have a question.
Yeah.
How did you get that -9 for your S plus 3 term?
So I used Wolfram. Yes, I used Wolfram, but if you wanted to do it by hand, we can go through that. So I typically like to just use different values for, well, first I'm going to solve for C because that one's going to be easiest. So solving for C, I get C is 9. And so I know, let me go back to the, is this green easier to read? No, it's still not. I got a different green, but it's still not easy enough.
Easier to see if that.
Yeah. I'll just use blue. Okay. So solve first for C, and you get C, and then you can solve for, I think, B. Copy this down. So when you multiply, bring this down too. And I multiply both sides. So this is also, oops, this is also easy enough to get A. So let S equals -3. So then from here I can get A. Or no, is this B?
Yes.
So B. So this will cancel, and then it's 9 times 10 to the -3. So that becomes a +1. So B is also, oh, sorry, this is 9 times 10 to the -3. And then now we know A and, or sorry, B and C. So then you can just pick a random number for S
Oh, okay.
and solve for A.
All right. Yes.
I like doing it that way. So, you know, I guess we can quickly do that. So let S equals 0. And then just plug in. So this would be 3 squared, 4, A over 3, and then 9 times 10 to the -3 over 3 squared. And then just solve that for A. And that should result in 9 minus 9. Yep. So anytime you have the repeated roots, it's hard to get that last number. And so just, you can pick any number and use the variables you already found.
Yeah, I was just wondering what to set. So.
Okay, yeah. And it can be any number at that point.
Okay.
And as long as you are equating them, you know, it will equate out. All right, other questions? Yeah.
Actually, keep this up. So my group did, we have I is equal to 27 times 10 to the negative 3 instead of 9 times 10 to the negative 3.
Well, this 1/3 on the bottom comes up, so this one right here, I bring that up to the top, so that becomes 3 times 9. 7 times 10 to the minus 3. Oh, yeah, I can write. 4 plus s. And then I itself, that's only Vx, so then I is Vx over 3. So it goes back to 9. And it's the same equation. Here's I. Vx minus 0 over 3. Okay. All right, any other questions? All right, we'll do a review on Monday. You want more imaginary? Okay.
Like when should I go to polar?
Okay, we'll go through some more of those. All right, any questions online? All right, have a good day. See you guys.